Hello everyone, it's Dmitry and Surfalytics, and we're starting our Model 4 about data integration in ETL. We'll talk mostly about what is ETL versus ELT, what is the batch. We'll learn different tools and we'll hands-on some of them. You will better understand what does mean transformation, what does mean orchestration, and what is the typical use case in the typical organization. That will help you to better understand and extend your knowledge from previous models. Then we learned databases, SQL, and BI tools. In our overall picture in the model, I didn't talk about how a typical organization looks like. So in other words, ETL helps us to connect our source system, right? There our business generate the data, and our target, our storage layer. So this is in a nutshell. I have here definition from Wikipedia. In computing, extract, transform, load is a three-phase process where data is extracted from an input source, transforming, including cleaning, and many other things, steps you can do, and load it into output data container or data warehouse or database or data lake or lakehouse, whatever you want. The data can be collated from one of the more sources, and it can also be output to one or more destinations. Usually, for data warehouse purpose, we have many sources, but we have the single destination. This is ideal use case. ETL process typically executed using software applications, but it can also be done manually by system operators or by code, and we'll look into this more deeply. ETL software typically automates the entire process and can be run manually or in recurring schedules, either as single jobs or aggregate into batch jobs. And there is also term DAG, direct acyclic graph, that is very common for dbt and Rflow, and some other BI tools like basic dependency of the jobs. We'll look into this as well. So this is a simple example of our very first step to just understand what's the difference between ETL and ELT. It's also a very common question on the interview. So assuming we have two files, one with orders and another with the products, and our goal to ingest it, it could be our Postgres database, it could be some cloud data warehouse, doesn't really matter. So in case if we'll talk about ETL, so we should have some kind of tool that some kind of standalone applications that can read these, or even if we're using just Python or any other script. So first, we need to open this file, we need to read it. So the tool or whatever thing is doing is it actually will read the file row by row. So it understands the files and maybe do some kind of cleaning operation, transformation inside of this tool or inside this process. And then result will be inserted into target table in the database, data warehouse, whatever we have. So the key thing that T-step requires us some kind of computational resources. So it requires CPU, RAM. So it requires individual like container or individual like server or where we can host this application. So the script that will do everything for us. And this is ETL. So it has some benefits and it has some disadvantages. On the other hand, we have ELT. So ELT, we have same files, orders, products, and we take those files, extract them. Yes, some process can open those files, but not necessarily to scan and read every line of code. So assuming we understand the schema of the file, and we can do the push down into our database or data warehouse. In this case, we don't need independent like intermediate process or intermediate applications or hardware, software that will do reading, transforming, cleaning, and pushing result. So we actually take this file as is and push into the table. Usually, if we talk about data warehouses, we have like staging area or landing area. So we just push it there, those files, and then we can do anything we want. The idea here that our cloud or analytical data warehouse is so powerful that it can simply read those files and process them, but we will use the SQL to do all kind of processing things with this. So, and in our case, we have orders, products as staging tables. They basically reflect the files, and then we can do some kind of merge and transformations to produce our sales fact table. So here we can compare one more time. What is it? So the both tools will extract the data. Then ETL will do the transformations. Inside the tool could be anything, like whatever you want. ELT will just do the load. And ETL, the last step is the load. For ELT, last step is transform. Very often the transfer will happen with SQL, Python, like it depends what kind of tool we're using. This is another very similar picture. This has the icon of Redshift. I took this from Matillion ETL, but the idea is the same. You see here, you have in the independent individual step, the thing that can do this, and here you don't have. This is becoming to the another term that we can using orchestration. The data orchestration, you can heard this, for example, Airflow, one of the most popular open source tool. It does the data orchestration. It can does data orchestration. So basically, it works in this method. So it means you need some kind of tool separate that will trigger this job on a schedule. So orchestration, the synonym is a scheduler. The cron scheduler in the Linux systems is basically the same. It can execute the script on the schedule, but orchestration tool, they have nice UI. Airflow, by the way, give you more flexibility. You can do this thing with Airflow, and this is very important to understand and literally feel the difference between ETL and ELT and what tool can do and not do. So it sounds like Airflow is a scheduler and orchestration tool that they only trigger our job, like take the file and push down this file into target data warehouse, and then data warehouse will trigger the scripts or maybe dbt or SQL mesh to do the transformation inside data warehouse. But at the same time, Airflow can actually, you can use the Python, you can read your files, you can connect the database with JDBC, do all kinds of transformations, and then push result, like final result, into data warehouse. So it means that Airflow is not simply orchestration tool that run jobs on scale. It can do the both, but for you, you need to understand it. The best way to understand it is take the Airflow, run it, and do those type of jobs. We'll maybe try Airflow. We'll try also another tool that is very old. It used to be open source called Pentaho Kettle. It was acquired by Hitachi. It has UI. It can do everything you need. It can be running on Linux, on macOS, on the Windows. You can schedule it. You can host it, whatever you can do. Nothing new. All the same things that you can find pretty any other tools it can do, but it has nice UI, and we'll probably start it for our starting exercise. So, batch model versus streaming. This is also a very important thing. So then we talk about ETL and ELT. We typically talk about the batch. Batch means it's happening on the schedule every 15 minutes. It's probably the minimum every 15 minutes, every 30 minutes, every hour, every day. I think most of data warehouse for complicated process, they refresh their data. ETL jobs usually runs overnight. For some better systems, it's running every hour and just adding new data. So this is the batch. The streaming, it means as soon as the event generated, it is going through different software like Apache Kafka or some Kinesis, whatever we're going to use, or maybe in Azure it's Event Hub, and it will push towards your landing storage. And usually the streaming works not really well with data warehouses. Despite the fact that Snowflake have dynamic table that supports this, it's still not that great. It works better with data lake system. They have file storage and you can just writing the files or appending or lake houses, but that's the streaming. And for streaming, we don't make our life complicated now with streaming. We want to understand the difference between batch and streaming and know that ETL, ELT, it's usually ties to the batch, and it usually ties to these separate tools like dbt, Airflow, and some others that can run on a schedule. The streaming, as soon as you start it, it's running 24/7. What is important notes? So in this model, we'll mostly use ELT and ETL and see the difference. We're not yet going to use any cloud data warehouses because my plan was using the Model 5 to actually dive deep into the cloud, like Azure, AWS, and GCP for data-specific roles, and Model 6 we'll use for cloud data warehouses like Snowflake, BigQuery, Synapse, Redshift, and maybe some others, whatever popular right now in the market. But here, let's just trying to better understand in very simple way, focus on ETL and ELT. Yeah, there is like batch and micro batch. Micro batch means it's like 15 minutes, or maybe like every 5 minutes if it's possible. It could be micro batch, and it's very important in other consideration because you can have full reload. It means every job will completely overwrite the data, or you can do incremental. Incremental, it means you only will extract the fresh data of the data and load the fresh data into your database. In the Model 6, we'll talk more about the partitions overrides, idempotent ETL, or maybe idempotent ETL will cover in this model, but it's not that important. The very important, yeah, you can do the full reload. That's very expensive, but very efficient because you write all the data, no problems. And incremental is slightly more complicated, but in incremental, you can have just simple append like delete and insert approach, or you can have more complicated like merge or upsert. And to better understand those different approaches, we'll use specifically dbt. dbt core is a free transformation framework. You will learn what is it, but why I like dbt, because it's covering all traditional data warehousing and ETL use cases, including the testings, the documentations, the performance-wise, and it works nicely from the terminal. It integrates with the Git systems. By the way, the Model 0 is important now because we will use the Git systems, we will use continuous integration, continuous deployments, we will use the Docker containers, and we even can run dbt in the containers using, for example, AWS Batch or GitHub Actions. All the things is very important to understand. They're not complicated if you tackle one by one, starting from simple concepts like what I covered in the Model 0. Some of terminology related to this model. ETL we already covered. By the way, this picture from Informatica Power Center. This was one of the most popular and the biggest tool on the market. I think recently it was acquired by another company. I don't understand why. Maybe Salesforce, but yeah, I don't understand why. Maybe they want to access their customer base, whatever they do, some complicated data movement inside for their customers. So ETL, ELT is clear. I already covered this. The job is actually like all your transformations that you created. This is the job, right? Then it can running on the schedule. For example, read Salesforce data, extract fresh accounts, do a bit cleaning, updating, and write into Snowflake and run it every hour. This is the job. The trigger, so this is things that might be, there are different trigger, could be just on the schedule, like every 9 a.m. it will start to kick the job, or maybe then you finish one process, it will trigger another job. So it's some kind of dependency when it starts. Event, because we can have event-based systems, and for example, we could happen certain event that will trigger the job, or event could be considered as just event that some actions happening. Because if you look to the source systems available for you to ingest data to your data warehouse, you can actually split it into two primary systems. One is traditional transactional OLTP based systems, for example, some backend for your e-commerce with the orders. Right, you have transactions and you can ingest the data. In other systems like Google Analytics or any kind of telemetry, that just every time event is happening, it create the log string or it create the JSON file. This is your event, and you can only append them. Nothing changed in the history. It's just event happening, and it's streamline or telemetry data into your system. The schedule makes sense. The condition could happen in your pipelines and your transformations. So could be anything related to this. Mapping, this is a great example of the mapping. It means you have a source table with the columns, you have target table with the columns, so how the columns map each other. This means mapping. Another term I didn't cover here is lineage. So lineage basically giving us information from the, assuming it's fact table, or it could be even dashboard. Somewhere from the dashboard, we can see what's the fact table, what's the tables it's using, and what's the source. This is like story end to end from the top to bottom, from bottom to the top. You can see all dependency, this lineage. And the mapping is lineage, but not with the table names, but with the columns. The sources, CSV, OLTP, SFTP, API. So this is the most popular. Also, could be some kind of applications itself, and often we can connect to applications. In the modern data system, we also talk about data share. For example, you can create data share in Snowflake and provide it to another Snowflake account, or you can do some cross query from Databricks to Snowflake, and so on. The target, it's usually where we write the data, our data warehouse, or data lake, and or lakehouse. Let's look some typical tools available. First one is very old, not popular anymore. Very similar, by the way, how the BI tools still work. Like Tableau and Power BI, you have client and you have server. So Tableau Desktop is a client and server where you host it. The same with BI tools. You have the client, you can modify everything on your local machine and then publish to the server. And the Informatica is a great example. This is an old picture. And by the way, this is on-premise. Ebito and in other systems could be only in the cloud, like most of them manage cloud, but by the model 5 will help you better understand what kind of cloud service models available, what does mean manage ETL, and so on and so on. But basically, you have tools that only available through the browser, like for example, Fivetran or Matillion, or the tools that can available also as a code. You can do the code modifications on your local machine, but it will trigger only everything in the cloud. So very different consideration. But this is a just example show the old systems how they look like, and the modern systems they look differently. And I hope after the model 4 you will have better picture what kind of things exist. So let's cover some frequently asked questions. So ETL and big data. So what is big data? I don't like use this term. Big data is not about the volume. Now most of the data is big. And maybe everything that's not fit on your laptop is a big data, but now you have laptops like MacBook Pro with 1 terabyte SSD, I think in 2 terabyte SSD and like 500 gigabyte. You have virtual machines in EC2 instance in AWS with more than terabyte of operation memory. It's a huge data, and it means you can use the single machine to run all your workloads, and that's why where DuckDB is popular, right? They're claiming you don't need like distributed systems to run your stuff. So by the way, the big data for me means, and maybe it should mean the same for you. You know there was the Hadoop as a history, and in model 1 I covered the history, and at some point in time was the Hadoop, right? The Hadoop, it's MapReduce, you have dedicated compute clusters like commodity, hardware, many clusters, and you have consolidated HDFS file storage that consists from many SSD disk and commodity hardware, but logically it serves as one huge storage with replications, pretty reliable. So, and we can call it big data. So big data technology, it's for me Hadoop ecosystems, is the Spark, is it Hive, Impala, but I think nowadays it's mostly Spark or Trino. Is it big data or not? I don't know. It's just SQL engine. I wouldn't put it into big data world. But everything what's related to the Hadoop ecosystems, this is big data technology for me. And we'll learn about Hadoop also later in like Model 7 will dedicate it to the Spark, and Model 8 will dedicate it to the big data itself. We'll look to some variations of managed Hadoop, and we'll look into Hive and some other things available for us. What is data pipeline? So data pipeline, for me, it's very similar to the job. That's the thing that do the transformations. And you think about data pipeline is coming from pipelines from the plumbers, but actually There is another theory. It's coming from the word pipe from the Unix. So, this was the symbol pipe that can divide commands. And basically, you have output and input, and then you can use input for you basically use output as input to another command, and you can like streamline your commands and transformations and just use the pipe to separate this. So that's why data pipeline is basically the same. You have dedicated steps. You read the source table. This is your input. You do some transformations. This is your output. You take this transformation, maybe join another table, and do some kind of transformation. This is your output. And then over, and then you do final do aggregations and write. So you see a bunch of steps and transformations happening, and this is your data pipelines. All this together, you can wrap as a single job that we can put on the schedule. And then we can build dependency. If one job will run only if the upstream job finish, and downstream jobs, including the refreshing of BI dashboards, will still waiting while jobs is succeed. And also, we're coming to the topic that jobs might succeed, but what's about data quality? Is the data is accurate? For this we have data observability and data quality to make sure we have enough tests and the data is accurate and ready to use. Whatever we see in the dashboards, that we're assuming to build dashboard in the model 3, so that the data makes sense. How you can have data make sense or not make sense? That's why the work of data engineer, ETL developer, to make sure that all the transformations is covering end-to-end by testings and the data is accurate and refresh on time. And then we're talking about the cloud systems. The cost is very important. How you can make sure that things you run is not that expensive. You don't burn your credits for Snowflake, for example. The next question, ETL or coding. But by this, I mean, you can use tools like low code or no code or like coding. Because nowadays with Python, Scala, even Rust, Go, you can build ETL tools end to end. It has some pros and cons. The biggest cons that to creating your own tools and using not common languages like Python is very common. But if you're going to use Rust, it will be very hard to find the people who, assuming you hire engineers, software engineers, they built everything for you from scratch, and then they left the company. And this will consider the tech debt and black box will be very hard to find another person to continue maintain this. Another person will come say, oh no, it's Rust. I will better use Go to replace, or maybe Python, and we'll start from scratch. Instead, way better to use the common tools in the industry. So this also will help you to understand what are the most common tools in the industry and what's the biggest community. And if you learn the right tools, of course, you will have better chances to get the job. You don't need to learn Rust to get data engineering job. Of course, you need to learn the Python, but even before you actually start learning code, there are many tools, low code, no code tools that can 100% cover all the needs of data organizations. Even dbt core, it's basically SQL. Right, just the SQL to do all the transformations, and with connection with Firetran or another tool, they can do ingestion for you. You can be covered 100%, and you can be very, very efficient, a high-paying like data engineer to do this kind of the job. So in our case, we definitely will start from no-code ETL tool Pentaha. We'll look some other examples available on the market, including dbt that is considered as a code tool, and maybe Airflow is an orchestration tool. But important thing about Airflow, if you're going to use Airflow, you need to know the Python. And you don't need to know Python as an expert. You need to able to read the Python. And usually it's good enough to understand what's the variables and what's the function, and how you can work with the Python package to have multiple files together, how you can call the Python. And with ChatGPT, LLM system, it's actually very simple right now, but you still need to do like the basics. We barely use classes if we don't want to create our own software. If we want to reuse existing software, we can do fine without classes. Another question, ETL and cloud. So of course, for the cloud, we have AWS, Azure, GCP, the most popular cloud frameworks. They have native tools. For example, in Azure, we have Data Factory. In GCP, we have Data Prog. I think all of them have managed Airflow. So they also have the Spark, and they have tools like BigQuery Redshift there who can create some store procedures or use their own tools to refresh the data. So a bunch of ways to achieve the same goal. So we'll start from very simple use case, localhost Postgres, no code ETL Pentaho, to play with it a bit, to understand the fundamentals, to understand, because we also have the topics like data modeling. We don't need to learn everything. We just need to focus on dimensional models, slowly change dimensions, fact tables, dim tables. Basically, how we can jump from row table, transaction table, to the star schema that we can fit to our BI tools. This is the bare minimum we need to do. And for this, we can use anything we want. Also, there are some old systems like integration systems, Oracle, SAP, Informatica that we don't want to try, but they still some big enterprise customers, companies might have them. But you will definitely understand the difference between ETL and ELT. And for Spark and Big Data, we'll definitely focus later in the course. ETL and data engineer. There is the job in the past was only ETL developer, person who works with tools like Informatica, integration service, connect the sources, knows well how to do transformations and how to use different kind of capabilities of the tool, and then writing to the data warehouse. On the other hand, the data engineer, this is the modern name of the person who responsible for data integrations and data storage. Batch, stream, ETL, ELT, data warehouse, data lake, lakehouse. So we will cover different functionality of those persons, from simple to more complicated, right? So of course you need to know the cloud. You be cloud fluent in the cloud, same like in the past people used to do. Same like in the past, people used to learn Microsoft Office because it was requirement. Like everyone should know Microsoft Office. Now everyone should know cloud. That's why Model 5 will cover everything you need to know for Model 5. Then the Spark, the most popular data engineering framework, right? It's only do computing. Model 7 will cover it. There is terms like data platform that might be data warehouse, data lake, lakehouse. Know the difference, pros and cons, so everyone quickly understand why and how to choose the certain tools. Basically, we're talking about system design for data engineering. Be clever in terms of how to work with data science, machine learning teams. What is feature store? Because data engineering can prepare data for machine learning and data science and help to put system in production. CI/CD, pipelines, continuous integration, continuous deployment, data infrastructure, including networking and security, infrastructure as a code. All those things is very important for modern data engineer. And we'll talk more about this. Then we'll start building more real systems. Data observability and the cost management. So you can see data engineer including way more than the traditional ETL developer, right, who works with the vendors and on-premise solutions. And also both of them need to understand how to do the different performance-based optimizations or cost-based optimizations. And they more or less like should know their systems well and manage their software and applications or their data infrastructure. That's it. For the next model, one more question. We already covered it. Batch for streaming. Now we mostly focus on the batch. And for streaming, it works well. Depends if you have some kind event-based systems that generate, for example, let's talk about authorization. Every time, assuming you have the mobile application, you have the form of authorization, every time that customers do login with event created. This event, you need to place to store it, right? You couldn't just hold them on the client device. You need to instantly send it to the server and land it somewhere in some kind of storage if you want to produce this. That's why the company tend to use streaming system, for example, Kafka, right? It can listen, it can sending events, for example, it will trigger event, send to the Kafka topic. Kafka topic will get it, process it, and then sending maybe right to S3 Connect, right? Writing to S3. So this is more complicated topic that we don't want to learn now. Very often there is dedicated platform team who doing this, and usually software engineers who working on this, but it's very good to know because this is, I consider, an advanced topic for data engineering. But to get the basic and fundamentals, we will focus mostly on the batch. You have some kind on the schedule system, so even if you work with data platform team, they're responsible for creating the streams, sending events to you, and then you can on batch, like every hour, come and pick up those events in the batch, process them, and maybe write to your data warehouse, data lake, whatever you want. That's it for now. The next lesson we'll look to ETL tools market, see what is out there, what tools available, and yeah, see you.